In this problem, we are asked to calculate the torque for each force acting on the bar. We are to assume that the axis is perpendicular to the page and passes through point 0. What is the net torque? In what direction will the object rotate? Okay, so here we have our point 0. It's going to rotate around this, okay? Either going clockwise or counterclockwise. You kind of look at this like the door hinge, and you've got a door off to the side. It's either going to rotate counterclockwise or clockwise. So that's what we're going to figure out. All right, so we're supposed to find the torque for each force. Well, I see a 20 Newton force, a 15 Newton force, and a 2 Newton force. So I'm going to go ahead and work my way left to right. So here we've got our 20 Newton force. Well, we have our equation for torque. Torque is equal to the force times the lever arm or distance times the sine of the angle, and that's the angle from the point of rotation down the lever arm and then in the direction of the force. Since we have 3 torques, I want to distinguish them. I'm going to call this torque 20 because it's the torque created by the 20 Newton force. So torque 20 is equal to 20 newtons times, we are at the point of rotation. So the distance from the point of rotation to the point of rotation is going to be 0 meters. And then times the sine of 40 in this case. So let's go ahead. Torque 20 is equal to 0 newtons. Okay, so this force does not cause the object to rotate at all. Think about that. If this is a door and this is the hinge, if you go to the door and you push right at the hinge, okay, you're not going to have the object rotate. It's just not going to go anywhere. Okay, you have to go a little further away. All right, so let's go ahead. Let's look at the next one. The next one we have is the 15 Newton force. So I'm going to say the torque produced by the 15 Newton force is equal to the force, which in this case is 15 newtons, times the lever arm or distance. In this case, I'm starting the point of rotation, and I'm traveling down until this point right here, and it says that is 2 meters. Okay, so I've got 2 meters. Times the sine of the angle. And the angle is the angle created when you start at the point of rotation, travel down the lever arm, and then go in the direction of the force. So this angle is not 32. It's this entire angle, which is made up of this 90-degree angle and the 32. So to find my angle, I have to take 90 plus 32 to get the entire angle, which is 122 degrees. Okay, so I can put that in, times the sine of 122. Okay, type this into our calculator, and we are going to find that the torque is equal to 86.5 newtons. Now, which way is this going to rotate? Well, I'm pushing in this direction. It's going to rotate in the counterclockwise direction, so this is a positive torque. Okay, next, let's look at the final force. So I've got this force down here, the 2 Newton force. So what is the torque created by the 2 Newton force? Well, that is equal to our force, which is 2 newtons, times the distance. Again, it's the distance from the point of rotation to the point where the force is being applied, and that distance is labeled as 4 meters. And then times the sine of the angle, and the angle is the angle created when you go from the point of rotation down the lever arm and then in the direction of the force. So I need this angle right here, which is not 24 degrees. Okay, it's going to be 90 here, and then over there I have to do a little bit of math. Okay, this angle right here and the 24 are complementary angles. They're going to add up to 90. So 90 minus 24 is 66. So this is a 66-degree angle right here. So I need to take 90 plus 66 to get my entire angle, which is 156 degrees. And then I can go ahead and type that in my calculator. 2 times 4 times the sine of 156. And we get torque 2 is 3.3 newtons. And now we have to ask ourselves, which way is this bar going to rotate due to the 2 Newton force? Well, this direction, which is clockwise. So this is going to be negative because it's going clockwise. Now let's look at the end. It asks, what's the net torque? And then the second part. So let's look at the net torque first. Remember, net anything just means add up whatever it is. So we're going to add up all the torque. All right, well, I've got the torque from the 20 plus the torque from the 15 plus the torque from the 2. Well, go ahead and do that. The torque from the 20 Newton force was 0 because it was applied at the point of rotation. Plus the torque from the 15 was a positive 86.5. Just realized I did my units wrong the whole time. Newton meters, Newton meters, Newton meters. Sorry about that. So it's a positive 86.5 Newton meters because it's going in the clockwise direction, plus a negative 3.3 Newton meters because it's going in the clockwise direction. We add all those together, we're going to get the net torque is 83.2 Newton meters. And then the second part says, in what direction does the object rotate? Okay, well this is positive, so since it is positive, it is going to rotate in the counterclockwise direction. Okay.